Okay, so we were looking at the present value of a series of payments. I asked on Tuesday if you would figure out what X is. When I go to solve for X, something interesting happens. If I move all of the thousands over to the other side, I then have to divide by the 1.06 to the fourth here. And when I reconcile the exponents, I end up with a sequence of negatives. Did you actually get a value for this? Okay. What I'm noticing though is I say, wait a minute, when I see 1 plus I to a negative power, we gave that a name. Remember what we called it? Aha. Which means this is almost a geometric series in V. There's just one extra V. So if I pull that one extra out, then I have a geometric series, right? What's the total of a geometric series? But in the future, yes, please print it out. When we had a geometric series that went from 1 up to V to the n minus 1, we got 1 minus V to the n over 1 minus V. So in this case, I'd end up with this. Now, if I actually plug this in, I'll get a number, which is in this case $3,465.11. So if I want to pay out $4,000 over the course of the next 4 years at $1,000 each year, then I don't actually need all $4,000 now. I'm going to earn over $500 in interest by leaving the money in the bank, and that's going to give me the necessary amount to end up paying out exactly $4,000. I like this idea so much that I want to try and generalize it. So let's consider, just like we did with the future value, bringing all those different payments forward, let's consider what happens as we bring all the payments back. So I've got n payments. And to make my life easy, I'll make each payment 1 for right now. If there are more than 1, I'll just multiply by whatever that number is, because like that 1,000 just ended up out front. At I% per period, then let's think about times 0, 1, 2, 3, n minus 2, n minus 1, n. The first payment is not going to be due today. It's going to be due at the end of the period. So I'm paying at the end. Here is the first payment. So its present value needs to go back 1 period, which means I multiply by v. I divide by 1 plus I. This payment of 1 also needs to go back. But it's going to go back 2 periods, so it'll earn interest twice. So the previous present value will be v squared. I don't need 1 today to pay you 1 in 2 periods. I need whatever the interest is going to be taken away. Same thing here. This 1 is a value of v cubed. And so on all the way up to here, which will have a value of e to the n. So the total, whoops, it's off the bottom. You can't see it. That's not good. The total of my value, present value, is this, which is almost geometric. It's not quite geometric because it doesn't start with a 1. So I could add 1 at the beginning and subtract 1 at the end, but I think it's easier to factor out 1v. Because then by my geometric formula, I get this. But here's a really neat trick. We said that v was 1 over 1 plus I. I would like you to do me a favor and rewrite that so that I can write I equals. Let's solve that for I. So I get that rearrangement? I.
How short is your new iPhone?
Where is it?
It's right there.
Oh, yeah, go ahead, go ahead.
Sorry.
It's okay. I didn't see one, so I was, where did it go? I was missing it.
I apologize for.
It's okay, thank you. So now that I have this version of valuation, notice that I have right here v and 1 over v. That means that 1 over I is v over 1 minus v, which means this really an I on the bottom. That's sneaky. This value right here gets used so often, I'm going to give it a symbol just like I did for the future value. Present value is going to be a n angle I. Now, I am very unhappy with using v as opposed to I, so I tend to write this a little differently. 1 minus 1 plus I to the minus n over I. The negative in the exponent there comes from the fact that V is 1 over 1 plus I. I need the same conditions here, well, almost the same conditions that I used for the future value. The payments must all be the same. The interest rate must be the same throughout the entire term of the loan. They all have to be made at the same interval, every month, every week, every 6 months, every 3 months, whatever it is. And that has to coincide with the period for the interest rate. The one thing that's different is my valuation date. My valuation date is one period before the first payment is due. The first payment was due at time 1, but my valuation date is at time 0. When we did the future value, my valuation date was the day the last payment was delivered. Here, I'm still making my payments at the end, but since my payment is at the end of the month, I really am thinking of my valuation as the beginning of the month. I believe this is the most commonly used formula in this textbook ever. What do you want to buy? You're going to buy a car someday? Do you own a car now? Joe, do you have a car? What'd you pay for it? Or did you pay for it? You didn't pay for it. That's nice and easy. If you were to have to buy a car today to replace the car you currently have, do you know what it would run you? You've got the computer open right now. Look up what that car or a similar model would cost today. Yeah, brand new car today. Even if you bought it used, we'll cut the number you give me in about half, just to give me a used car price. I don't know. You want to buy a used car? Or do you want to buy a new car? Okay, we'll go with a new car.
$33,142.
So I'm going to round it, $34,000.
I don't know you want it.
I'm sorry?
I don't know you want it exactly.
No, I just want to get an easy number to work with for now. But do you have $34,000 in your pocket? So you're going to finance this car. Who are you buying it from? Do they have anything about finance rates on their website? Because if not, we'll just make shit up. Okay, again, I'm going to round. Let's go with 2%. 2% APR for how many years? Or months. They usually give it in months.
60 months also.
So 60 months, that's 5 years. So you're going to pay this car off over 5 years at 2%. By the way, 2% is really cheap money. How much you paying a month? I can do that calculation right here because that's the monthly payment on the present value. I need to borrow this today. If $34,000 is my present value and I'm going to make some payment for 60 months at 0.02 over 12 per month, I can work this out and get exactly how much we're going to have to pay. So 34,000 K parentheses 1 minus 1, what's 0.02 divided by 12? Going to be some ugly repeating decimal. Well, should have picked a better interest rate, but oh well. 0016 repeating. To the negative 60th over 0.0016 repeating. Right? So I just have to divide by this to get K. I'm actually going to write it upside down. 34,000 times 0.0016 repeating over 1 minus 1.0016 repeating to the negative 60th. Out comes my calculator. Let's run the number. 0.02 divided by 12. Rather than me keep writing these decimals down over and over, I'm going to store this number. There's a store button at the bottom left of my calculator that puts that answer in a letter for me. So I'm just going to use A for my interest rate here. So now it's 34,000 times A divided by 1 minus 1 plus A to the negative 60th. My monthly payment on this car is $595.94. Ta-da! Now, is that a payment you can afford per month right now? Maybe, maybe not. And if it is, great. If it isn't, you negotiate the loan. A longer term will lower your payment at the same rate. Banks know this, and they may adjust your rate for longer term loans. By the way, the last payment may be slightly more than $595.94 by a couple of cents. Why? I rounded down. That 0.3 cents will accumulate over time. I may be off by a penny or two at the end of 5 years. You want to buy a house? Same process. If you buy a fixed rate loan, a fixed rate mortgage, you can figure out your monthly payment. Now, if you round off the interest rate to a certain number of decimals, you may be, again, differing by a couple of pennies. That's fine. Joe, question. You look at your calculator, you look like I'm talking to me.
Yeah, I was just seeing how much you pay on top.
What do you mean on top?
Like, you have a monthly payment, you see how much basically, or I'm just seeing how much. Extra it was.
Yeah. So my total finance charge, I take this amount, my monthly payment, multiply by the number of months, and subtract off. I paid about $1,760 extra for this car. I was just saying, money at 2% is really cheap. When I bought my car, the loans were at 6%. When I bought my house back in 1992, those loans were at 8%. I refinanced at 5%. Mortgages right now are running 6%. Car loans are running a lot more than 2% in some cases, depending on where you are.
I'm pretty sure. We did, like, I had Mazda, but we did, like, my family got the Mazda because the interest rates for Mazda were so low.
Yeah, absolutely. When I bought my first car here in Pittsburgh, again, interest rates I think were at 6%, but there was an offer that you could get it with nothing down. And the first payment wasn't due at signing, it was due later. So it very much fit this mold. I think my payment for that car was $218 a month. So you will often see this regular payment instead of a K referred to with an R, like rent. If you're buying a house, right? Same idea. As our interest rate goes up, our present value goes down. Why? That's not something I'll see here, but if I look back at this, why does it make sense that as my interest rate goes up, my present value should go down? Maybe not from the formula, maybe just from the time diagram. If my interest rate goes up, why would this number go down?
By interest.
Aha. If I've got a higher interest rate, I will earn more money each period, right? That means I need to put less in to have that same amount. Now, that means as interest rates go up, if I need to borrow the same amount, my payment has to go up. Or if I know that I'm just cashing in a series of future payments, then that value is going to go down. A payment further into the future is less valuable today than a payment closer to the future. A payment in 1 month is worth more right now than a payment in 6 months because of the interest difference. If I'm going to wait 6 months, I could put the money in the bank, earn more interest. So today I would pay less for that future amount. Consider a dividend, a stock that pays you $2 every month. I know it's a trivial amount. Buy 100 shares, get $200 a month. Okay. You say to somebody, I have this piece of paper. It's worth $200 on October 11th. Interest rates right now are about 3%. What do you give me for it? Well, you take out the 3%, right? You divide by 1.03. That's how much this is worth today. But if I tell you it's going to be worth $200 in October and 200 more in November, when you look at the 200 in November, you have to divide twice. So that November payment is worth less right now than the October payment is. Even though they're both $200, the time difference makes a substantial difference in value. Questions? Apps, finance, solver, 60 payments at 2%, a present value of 34,000. I made it negative because that's money going out. A future value, I'm going to pay off the car, right? I'm making 12 a year. At the end of each month, solve for the payment. There you go. Same exact calculation we did by hand. It did automatically. So let's see what happens if I change that from 5 years to 6 years. Change this to 72 months, resolve for the payment, and my payment goes down almost $90. But they'll earn more from me in interest because I'll be paying it for a year longer. Make sense? Questions? I know I've seen car commercials that say no payments for the first year or the first 6 months. You don't have to start paying for 6 months. What changes in my formula? So let's take that car loan. It's going to be 5 years long, 60 payments. But instead of starting the payments today, I'm not going to start them September, October, November, December, January, February, March. I'm going to move it 6 months. Your first payment is going to be due, valuation date will be 6 months from now. So we'll start the payments in April. Because if you bought the car today, the first payment would be due a month from now, right? Time 0 versus time 1. I can also think of it as I was going to buy the car with a start date in April. So my valuation would have been March, but now I'm backing that valuation up to today. That's what I would pay starting today, right? That's the payment we just came up with, the $595. But I want to move this back 6 months. What does that mean in my time diagram? Let me go back and look at that picture again. What does that mean for this payment?
What have paid for?
This date is not today. This date is March. So when I go to think of today, today is back here somewhere, right? Means I've got to move back 6 more slots. Right? So instead of just having a V, I'll get V to the 7th because I will have moved this back 7 times. And here I'll get V to the 8th, and here I'll get V to the 9th. So every one of these will have more V's on it, right? That means when I do this factoring, I'll factor out 6 more V's. Which means here, I'll have 6 more V's. Which means here, I'll have 6 more V's. Because I backed up the payment structure 6 months. So I could literally say, wait a minute, I know this gave me a K of 595. Now I just have to divide by this. Boy, that's the same as multiplying by 1 plus I to the -6th, isn't it? Bringing everything back further. Because I'm not actually going to not pay interest. They're not going to let me just sit there on this money that they've given me for 6 months. They're still going to charge me interest, but I don't have to pay it. So that interest accumulates, and each payment goes up because it accumulates this additional 6 months of interest. So quite frequently, when you see a deal that says pay nothing now, they're still charging you interest. They're just delaying the onset of the payments. That's why we went up. That's a number bigger than 1 being multiplied in by however long we delayed. Example 2.7 on, I didn't write down the page number, has 2 different car payments. It's a $12,000 loan. It's either at 12% or at 15%. That's a more outrageous car payment right now, given the interest rate environment of today, but it's also a reasonably nice number to work with. And then later, example 2.8 just says we're going to delay the payments for 9 months. What does that change? So there are two other examples in the textbook that follow this idea. So our original valuation date is one period before first payment. So when I said we're going to take the loan today, but the first payment is October, and then I said, no, we're going to think about delaying that 6 months. That made my first payment April. Instead of bringing it back once, I brought it back 7 or 6 more times. And that's why I didn't put a v to the k plus 1. I just put a v to the k. This is called a deferred annuity. Deferrals show up a lot, and we deferred by k payments, by k periods. There's a notation for that. This little k and bar in front of my ANI. It is still a subscript. This bugs the snot out of me. I really don't like it. But I can have that same equation that we had at the end of class last time, and I can say that A n plus k I is a k plus v to the k a n. Those both get i's. Or I can switch those two pieces and I can write a n I plus v to the n a k I. Notice that the power of v is opposite the subscript on that a. So there are two types of present value. There's the present value one period before, and there's the value several periods before. One period before is an ordinary annuity present value. Multiple periods before is a deferred annuities present value. Questions?
Or when we put V to 6, shouldn't be V to 7.
That's exactly what I'm talking about here, right? In the original setup for that equation, we'd already pulled one of them out, right? So that takes care of one. So instead of saying, oh, I moved back 7 months, I already took one of those, so I only need to take 6 more. My first payment would be due here, but my valuation is here. So this is today, right? September 11th. This payment is October. And now I tell you, oh, your first payment isn't October, it's April. April is 7 months away, right? But I'm only moving your payment 6 months forward. So instead of v to the 7, it's v to the 6. And that's why here, moving it k plus 1 periods only puts in a k, because we already moved it by 1 period in the original formula.
So that 1 period is just factoring out.
Yeah. So we can try and rearrange this to figure out what happens if you don't do that. What if your first payment is today? Then it would be different, right? We'll get there, I promise. I'm just not there at the moment. I don't know why the book decided to put those in 2 different places, but I do have that difference style, and I hope to get to it today. Ready? Did that better for you, or are you still, okay? So when we did annuity future value, we looked at what happens when things change. Let's do the same thing for present value. What if my interest rate changes? Now, I don't like the idea of taking a car loan with a fluctuating interest rate. I don't like the idea of taking a home loan with a fluctuating interest rate. But those loans are out there, and they're useful to a lot of people. So really what I'm thinking of is this is the interval from 0 to n, and this is the interval from n to n plus k, but notice closed on n, open on n. All right, so let me think. Normally I would just say, oh, we're going to do the first n periods at I1. That would make sense, right? Let's ignore this change for the moment and just worry about the first however many periods. Maybe your interest rate is only 2% for the first 2 years. Hey, wait, don't they even call them introductory interest rates? You get these on credit cards, right? Transfer your balance, and for the next year, you'll only pay 1%. And after that, we'll go back to our normal rates. So 1% for the first year, and then 9% after that. Oh, if I take these and I bring them to this point in time, then I would be, oh, well, we're only looking at the new stuff for K periods, right? That didn't bring it back far enough. Those payments are now valued at time N. How do I bring those payments back to today, time 0? How do I adjust these to have time 0? I'm bringing this back a certain number of periods, right? Bringing back by periods is a deferral. If I'm bringing back by periods, I need to know how many periods I'm bringing it back. From n to 0 is how many periods? You're counting from 0 to n inclusive. How many numbers did you count? Count from 0 to 5. How many numbers are you going to count? 0, 1, 2, 3, 4, 5. Crap, that's 6 numbers. I'm counting from 0 to n inclusively. I'm going to count n plus 1, right? Deferring by n plus 1 means multiplying by v to the n. Now, there's just one problem. That v. There are two interest rates in this problem. There's interest rate 1 and interest rate 2. Which v is that? The value v is 1 over 1 plus I. Is that I1 or I2? During this period, we are charged interest rate 2. During this period, what interest rate are we charged? Which means this v is in this period because we're moving the thing back this way. That means this is VI1. I have to think of the interest rate and the times it overlaps. An example. I take an adjustable rate loan for 3 years. The present value of my loan is $10,000. I'm spending $10,000 on something. During the first year, I pay 6%. Converted monthly. So that 6% is an annual rate, but I'm compounding monthly. In the second year, it goes up to 9%. And in the third year, it goes up to 12%. Now, since I know what the rate schedule is going to be, I can then say, how much am I going to pay every month if I want to make the same payment every month? I don't want my payment to change in the middle of this. How much am I going to pay every month? Or maybe I'll say, well, I know, as years go on, I'm going to get a raise. So maybe I can let my payment go up a little. I'm going to make a structure. Let me say, in the first year, I don't know what the payment's going to be. But in the second year, I'll get a raise, and I think I can afford to pay an extra $25. And in the third year, I'll get another raise. So let's pay another $25 or $50 total more. This is complicated. Yes. But let's work out my payment schedule. Let me think about what I can do. Here's time 0, 1, 2, and 3. Here, my interest rate is 6%. Here, it's 9%. Here, it's 12%. I'm paying monthly, so we'll divide all of those by 12 when we do the actual calculations. Here, my payment is X. Here, my payment is X plus 25. And here, my payment is X plus 50. So let's think about the present value at time 0. Let's think just about the first year for a moment. Ignore all the changes we're making in year 2 and year 3. If I just look at the present value for year 1, my present value for year 1 is my payment, 12 payments of 0.005. Why 0.005? Exactly, 0.6 divided by 12. Now, in year 2, I'm making a new payment. I'm doing it for 12 months, so I'm going to do A12. What's the interest rate during this year? But it's per month, so it's 0.9 divided by 12. Great. Now, if I just calculate this, that's the value at the beginning of this year. I need to bring it back a year. So I need to multiply this by v to the 12th. But what interest rate is that v got? That interest rate is for this year, because that's the year I'm bringing it back during, right? So that's v 0.005. You'll notice I put the I at the bottom so that I know what's going on there. Make sense? What about year 3? There's my payment. If I was just looking at year 3, I'd do the annuity for 12 months at 0.01. But that only brings me to time 2. I need to crank that all the way back to time 0. Well, that means I need to move it from time 2 to time 1, and then move it from time 1 to time 0. Because those have 2 different interest rates, I'm going to use a v to the 12 with a different interest rate between year 1 and 2, and then a different rate between 0 and 1. So to go from 2 to 1, I have to multiply by v to the 12, but that's v 0.0075. And then to go from 1 to 0, I need v 0.005 12 times. Isn't this just disgusting? But that's my payment schedule for this loan. How much was the value of the loan? $10,000. So 10,000 is equal to X A12.05, 1 minus 1.005 to the negative 12 over 0.005, plus X plus 25 times 1 minus 1.0075 to the negative 12 over 0.0075 times 1.005 to the negative 12. Remember, I told you I didn't like writing v as 1 over. I'll just write it as negative exponents. It's me personal peccadillo of mine. You're welcome to leave them as V's. Plus year 3. X plus 50, 1 minus 1.01 to the negative 12 over 0.01 times 1.0075 to the negative 12, 1.005 to the negative 12. Now, I'm the crazy SOB here. I can't do this in that time value of money solver on the calculator in one step because the interest rate kept changing. And the TVM solver only works for constant interest rates. So I need to calculate this number. I need to calculate these two numbers and multiply them together. I need to calculate these 3 numbers and multiply them together. And then I can solve for X. The first number right here, 1 minus 1.005 raised to the negative 12 divided by 0.005. Now, I'm going to be a pain in the ass and keep all the decimal places until the end. So this number right here, 11.61893207. Now I need these two numbers multiplied together. 1 minus 1.0075 raised to the negative 12, close the parentheses, divide by 0.0075. That's this number. Multiply that by 1.005 to the negative 12. That number gets multiplied by x plus 25. Now I need a product of 3 numbers, so I'm going to get x plus 50 times. Here we go. 1.01, do it right, 1 minus 1.01 to the negative 12 divided by 0.01 times 1.0075 to the negative 12 times 1.005 to the negative 12. 9.692037592. Hey, wait a minute. This is now just a linear equation. I have number times x plus number times x plus number. How many x's do I have altogether? Take this number to x, this number times x, this number times x. So I have to add those 3 numbers together. And I get 32.08157497. To get the plus, I take 25 times this number and 50 times this number. What do you get? And that's equal to 10,000. Subtract, divide, solve for x.
Just 2004.
207, right?
Yes.
This is actually dollars and cents. I'm going to go ahead and round that up. 207 becomes 21. Even though I know I can afford a little more as time goes on, I can afford 25 bucks more next year and 50 more the year after that. I don't know how much the payment's going to be up front for me to say I need 10 grand right now. Oh, this month it's going to be this year it's going to be 288.21. That's the first year payment. And in year 2, we add 25 bucks to this. And in year 3, we add 50. There you go. 313.21 and 338.21. So now I budgeted for the full 3 years. If you wanted instead to make one level payment across the entire thing, that would be a higher payment year 1 relative to the interest rate years 2 and 3, right? I'd be saying, well, I know I'm going to pay more interest there, but I can account for that by paying a little bit more this year than waiting to the future for that interest charge to come in. Make sense? It's an ugly calculation, I will guarantee you that. But everything that has an introductory interest rate works just like this. Most people don't actually pay a lot of attention to that working the payments out in advance. They think of that low introductory rate and like, I'm going to save money. Well, yes, at the beginning. My father decided as a joke, he was going to screw the credit card companies as hard as he could. And he bought a car on a credit card. He had enough room on a credit card to pay $18,000 for a car. This is 1980, whatever. So $18,000 was a pretty good car. But he put it on the credit card. The credit card offered 0% interest for 6 months. What did he do on month 5, day number 27? He got a new credit card that offered 0% for 6 months and transferred the entire balance of what was left. He'd been paying on it every month, so it was now like $15,000, but he moved it to a new credit card every 6 months for the 3 or 4 years it took him to pay off. It paid no interest. You can get away with it if you're lucky.
So for the interest, you're not paying interest on the credit card. Do you still pay interest on the car itself, or?
Because he paid cash for the car, right?
Uh,
He walked in and said, here's $18,000. I borrowed it from you. Here's $18,000. The finance company, there was no financing on the car. He paid for it in cash, effectively. But it takes a lot of work and a lot of detail. And you had to make sure the person who opened the new credit card for you, I need a credit line of $15,000, isn't something most people will get right away, right? You'll get a $1,000 credit card, maybe a $2,000 credit card. You won't get a $15,000 credit line unless you're an established individual with a good amount of money in the bank. So the fact that my dad had a credit history for 40 years and could do this meant that he could credit card hop for 3 years. This was right about the time Discover Card was coming out. So they were offering 0% interest for a year rather than 6 months. And other cards were then trying to make up for it. Oh crap, Discover Card's taking our business.
you go up over.
Can I what?
Go up over.
Yeah, how
The 1 minus that 1.0 minus the -12 over 0.01.
Yes,
Is that just what we like?
this,
That's before what we solved for VS. Like,
well, this is actually the A. These are the A's. This is this. This is this. And this is this. The V calculations, that's these numbers. Oh, you can't see the crap I'm circling up at the top. There. This is the formula for A N I. 1 minus 1 plus I to the N, 1 minus V to the N.
That's what I was saying.
Yeah, V. Yeah, V is 1.1 plus I to the negative whatever power. That's the thing I keep writing. Whenever we write V to the N, that's 1 over 1 plus I to the N. So that's 1 plus I to the negative N. That's the only difference. Having an extra letter in there is the part that makes me twitchy. Every time I see V, my brain goes, turn that back into I, turn that back into I. So that's what I keep doing. This A calculation is really just saying present value. Here's a comparative behavior. Here's a timeline going from time 0 to time N. Whatever my deposits are, when I think of bringing those deposits forward to here, that's SNI. But remember, that meant there was a deposit here and here and here and here and here and here. Notice there's no deposit here. But when I think of the present value, I'm thinking of bringing that to there. One period before the first payment is made.
So that's present value.
Yeah. So this is future value, and this is present value.
Present value, you don't have.
There's no payment on that first date. That's the weird part. For an ordinary annuity, we think of the payments being made at the end of the month. So I signed the contract on September 1st, but my first payment isn't made until October 1st. I keep paying for 5 years, right? I'm going to make 60 payments. That means my last payment is made in September 5 years from now. That's this date. October 1, November 1, December, January, February, March, April, May, June, July, August, September. The end of the year is September, even though I'm making my contract on September. I don't pay until October. Now, notice the difference is simply which direction that arrow is going. And that one extra month for the present value. That's our formula from Tuesday. We used our geometric sum idea. J. No, if I'm using 0 to n minus 1. I think I've written this down wrong. Hang on a second. Yes. 1 to n j minus 1. There we go. Now, let's look at an. ANI. The present value versus the future value. Let me go back to the very first thing I showed you at the beginning of class. We're going to be able to pay 1,000, 1,000, 1,000, 1,000. And we worked out that that meant I only needed 3,400 today. But I could also say, let's take each and every one of those payments and move them forward. That's the formula we just came up with for present value. Do you see now why having the V and the I bugs me? I'd rather just have I, that's why I write it like this. But now let's compare these two. I'm still subtracting on the top, right? I'm still subtracting on the top. There's still an I on the bottom. So the only difference between these two versions of the formula is where that 1 plus I to the n is. Which means I can think of taking this expression. What if I multiply this whole thing by 1 plus I to the n? What do I get? Oh, wait a second. I'm going to have a 1 plus I to the positive n multiplied by a 1 plus I to the negative n. What's going to happen there? Which is going to give me 1 plus I to the 0, which is just 1, isn't it? Then I multiply this by the 1, and I get 1 plus I to the n. Wait a minute. ANI times 1 plus I to the n is SNI. Literally, the present value. Do the compound interest all the way forward, and you get the future value. They're the same number. It's just what time are we looking at it? Are we looking at it today? Or are we moving into the future and looking at it then? Which end of the timeline are we at? Are we at this end or this end? What's happening in the middle is compound interest. By the way, if you divide this to the other side, it becomes 1 plus I to the minus n, right? But that's V. So another way to write this same thing is to say that the present value is bring it all back to today from the future value. These two formulas are on page 86 and will be useful to us. If I know the value at any time 1, and I want the value at time 2, I just need to multiply by the appropriate factor of 1 plus I to the difference in times. If I'm going forward, it's time 2 minus time 1. If I'm going backwards, it's time 1 minus time 2. This factor of 1 plus I to the n allows me to slide my valuation around. This is what we did within the payments in the first place, but we were trying to pick a valuation date. That was like 2 weeks ago in chapter 1. I said we could do it in February, we could do it in March, we could do it in a day in the middle. It didn't matter. And then if I adjusted the 1 plus I, when I go to solve, I get the same equation regardless of which day I pick. This is the way to adjust for that. All right, I'm not going to quite get to the difference between doing it today and doing it 1 month from today. That'll have to happen on Tuesday. Questions?
So be back to this, it's be in one, it would do 1 plus
Right.
at the end, you just, and then. Let's make sure I have that one, right?
Yes. Okay. So here's a weird idea. You put money in the bank. It's going to earn interest all year, right? You take money out of the bank every month. What if you never go lower than the amount you put in at the beginning of the year? At the end of the year, all you've spent is interest, right? Which means you didn't touch the principal at all. My parents, who are retired, like to do this because it means, hey, we started this year, I'm making a number up out of thin air. We started this year with $1,000. We ended this year with $1,000. We spent money in between, but we lived for free. The money the bank paid us is the money we used to do things. I never spent any of my own money. That $1,000 is still sitting there. Which means next year's interest, if it's the same as this year's interest, I can do it again, right? A perpetuity is an annuity that goes on forever. There was a Pennsylvania lottery ticket that I remember, something like $500 a week for the rest of your life. Can you imagine every Sunday night, your bank account gets $500 for the rest of your life? How much do I need in the bank today to be able to do that? What if I told you that you could take that reward and give it to your children, and they could give it to their children? This amount is going to go on forever. That's a perpetuity. This question right here, how much do I need today to do this, is a present value question. So I'd like to think about what happens to my present value idea as time goes off to infinity. But I'm clearly not going to do that today because I've just hit the clock. So we'll pick this up not Tuesday, because what are we doing on Tuesday? Yeah, the first exam. So I know what I'm doing this weekend when I write the damn thing. I will grade your homework. I will get it back to you as fast as I can. Because I'm getting a homework assignment late, I will email you guys the keys now. Don't share it. But as soon as I get hers, I'll post the key to our Canvas page as well. The exam will look like the homework questions. I'm not gonna pick the crazy ones, I promise. It will be doable within the 75. If you've got questions between now and then, come bug me. I will happily talk to you about the exam or the homework. Enjoy your afternoon. I will see you all on Tuesday.